video. This is the third and final video for Calculus of Polar. And we're going to do a couple more arc length problems, and then I'm going to show you how to find tangent line. Okay? Now, we're just going to keep using the same printouts because that makes it a little more familiar. We're already familiar with the particular thing, with the particular functions or equations. Now, let's go ahead and remember that I used this portion of the graph the last time around. Let's see if we can actually find that length, right? And again, because it doubled, we can actually use the symmetry to our advantage, and we don't actually have to find both sides of it. We can find one side of it, and then we can just multiply by 2, right? Now, if we remember, this was, this portion of it up here, from here to here, right around here, was the interval negative pi over 4 to 3 pi over 4. Okay, and we can go ahead and reconfirm that. Remember, I haven't even deleted it from the calculator yet. Go back to the window. That's negative pi over 4 to 3 pi over 4, and that's the portion of it. Okay, so if we have that, and of course that was the sine one, that was this one, then we have most of what we need. We have r, right? R is 3 minus 3 sine theta. R prime is going to be negative 3 cosine theta. We have our limits of integration. So we have negative pi over 4 to 3 pi over 4, right? Okay, and then all we have to do, and we'll go ahead and put a little line right here, that's L, is we just have to set up the radical. So we need r, 3 minus 3 sine theta squared, plus negative 3 cosine theta squared times d theta. That's going to be our integral, and I have no idea whether it actually is, we're capable of doing it by hand, but we're certainly capable of plopping it into the calculator and having it execute it. But remember, that was just half of it. So we would need to go ahead and multiply it by 2 in order to get this lower portion of that perimeter, of that weird intersection shape. Okay? Well, let's go ahead and let's go back to another one of our previous graphs. Okay? And let's actually find, let's go ahead and find, just like this past time, let's find the perimeter of the area for which we found the area earlier. So we wanted to find the area of that region that was enclosed by both, and now I want to find the perimeter of that region. Well, again, dealing with this portion ought to be easy enough, okay? And remember, I messed this up. That's actually 1 minus cosine theta, right? And so what we need to do is we need to, let's see, that's 1 minus, right? Hold on just a second. Let me, 3. Just go ahead and show again. Remember, that is what it looks like on the calculator, just to remind you that it is 1 minus cosine theta, because I messed up the sign the last time. Sine, S-I-G-N, right? And so what we need is we need the length of the semi-circumference, and then we need to add it to 2 times the length of the hump, right? That really technical term that we used the last time. Now I recognize the fact that this right here is theta is equal to 0. This right here is theta is equal to pi over 2. Now, that means that the length of the semicircle is going to be, of course, 2 pi r, so it's 1/2 times 2 pi, and r is, of course, 1. And then it's 2 times the length of the hump. Well, the length of the hump runs from 0 to pi over 2. And then you have the square root of r. Well, r winds up being 1 minus cosine theta squared. And then if you take the derivative of that, it winds up being sine theta squared d theta. And that should be the expression which gives us the total arc length around that region that we found the area of the last time. Okay, that's simple enough, okay? And so that basically brings to a close our discussion of area and arc length for polar functions, polar equations and scenarios and stuff like that. What I want to do now is I want to ask you a question, and let's go back and let's actually look at this one. Again, remember, it's 1 minus cosine. And I want to find this tangent line right here in terms of x and y. And you say to yourself, it's in terms of r and theta. How in the world are you going to do that? I'm so glad you asked. Because if you remember those conversion formulas we used when we were first being introduced to polar, we have the fact that x is equal to r cosine theta, and y is equal to r sine theta. And when I say r, I mean this r, okay? So if we want to basically parametricize our polar equation, so to speak, then this winds up becoming 1 minus cosine theta times cosine, or cosine theta minus cosine squared theta. And this winds up becoming 1 minus cosine theta times sine theta, or sine theta minus sine theta cosine theta. Now that it's in parametric, I can now find dy d theta, dx d theta, put them in a nice ratio in order to find dy dx, right? Okay, so let's go ahead and do y prime. That's cosine theta. Okay, well, see, I don't like the fact that I'm going to have to do the product rule here, so why don't I just creatively use the double angle identity and make that 1/2 sine 2 theta, okay? And therefore, when I take the derivative of that, it winds up being minus cosine 2 theta. Let's go ahead and do x prime. That winds up being negative sine theta minus 2 cosine theta times negative sine theta, or negative sine theta plus 2 sine theta cosine theta, so plus sine 2 theta. So now I have x and x prime, y and y prime, and so I can actually get dy dx in terms of theta. It's cosine theta minus cosine 2 theta over negative sine theta plus sine 2 theta. I can evaluate that at 3 pi over 4. I can evaluate x and y at 3 pi over 4 to get myself an ordered pair. Then I'll have an ordered pair, and I'll have my slope. Okay. Well, let's go ahead and move on to the next page, and let's actually do this, okay? So we need to find a point and a slope. But now that we have everything in parametric form, it winds up being rather simple. So let's go ahead and evaluate x at 3 pi over 4. And that winds up being, and we're going to do it in the factored form, 1 minus cosine 3 pi over 4 times cosine 3 pi over 4. Now remember, cosine in the second quadrant is negative, so that's 1 plus root 2 over 2 times negative root 2 over 2, or actually probably better to do 1 over root 2, sort of unsimplify it. Okay, And so that winds up being negative 1 over root 2 minus 1/2, or if you want, negative root 2 over 2 minus 1/2, or negative root 2 minus 1 over 2, right? So that's, it's not pretty, but it's workable, And so we have y of 3 pi over 4, and that's not going to be much prettier, but it's going to be 1 minus cosine 3 pi over 4 times sine 3 pi over 4. So we're using the original x and y parametrics in order to find the ordered pair. This is going to be 1 plus root 2 over 2, and this is going to be positive root 2 over 2. So you're going to have root 2 over 2 plus 1/2, or 1 plus root 2 over 2. Okay. Now that we have the ordered pair, negative 1 minus root 2 over 2 and 1 plus root 2 over 2 point. Now we need the slope. Slope is going to be a little bit nasty, but not overly burdensome. And you're like, oh my gosh, it's already taken 2 pages. Well, I am writing big so you can actually see it, so I don't think it would actually be that bad if you were writing your normal size on a test. And this actually is kind of a nasty one. So cosine 3 pi over 4 minus cosine of 2 theta, so that makes this 3 pi over 2, negative sine 3 pi over 4 plus sine 3 pi over 2. Well, cosine of 3 pi over 4, we've already figured that out. That's negative root 2 over 2. Cosine of 3 pi over 2 is going to be 0. Sine of 3 pi over 4 is going to be positive root 2 over 2, but you have that negative out in front. And sine of 3 pi over 4 is negative 1. Okay? And of course, that really is 1 over root 2, negative 1 over root 2 minus 1. So you can multiply it by root 2 over 2 and leave yourself with negative 1 over negative 1 minus root 2. Let's go ahead and turn all of that positive. And that right there is your slope. Point slope. So 1y minus 1 plus root 2 over 2 is equal to 1 over 1 plus root 2 x, and you can actually go ahead and put plus if I sort of extract the negative out of the numerator of that x. And as messy as that looks, and as burdensome as the arithmetic was, it really actually wasn't conceptually difficult. It was just tedious, right? So all you really have to do in finding the equation of a tangent line in x and y is just remember that x is r cosine theta, which basically transforms it into x is equal to r theta as a function instead of as a number that we're used to dealing with, but it's the same principle. That winds up being your x in terms of your parametricizing. Y is equal to r sine theta transforms into y is equal to r of theta as an equation, as an expression, times sine theta. And then you just go ahead and move forward and find the equation line, the equation of the tangent line, the way you normally would with parametrics. There are some books that actually, give you a formula for the slope, and I find that just to be why in the world would you memorize a formula when you don't have to? This is straightforward enough. You already know how to find the equation of the tangent line in parametric form, and all you're doing is transforming the polar into parametric in order to do just that. We'll go ahead and call it quits on polar. I hope these videos have helped. That brings us to a close of this particular chapter. Good luck on the tests. Send me any emails with any questions you might have. Blah, 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 blah. Goodbye.